Hello students, continuity and differentiability is a very important topic. Today we are going to study continuity of functions with the help of examples. Watch the video till the end. To understand the concept of continuity, let us take some examples. Consider fx is equal to 1 if x less than or equal to 0 is equal to 2 if x greater than 0. The graph is shown over here. Now, at the point x is equal to 0, let us try to evaluate the limits, the left hand limit and the right hand limit. That means as x tends to 0 from the left side, you know that the function will take the value 1 by the definition of the function. And as x tends to 0 from the right side, it will take the value 2. So the left hand and right hand limits don't coincide. That means we can say that the limit does not exist at x equal to 0 as x tends to 0. Now also when you try to draw the graph, we cannot draw it with one stroke. That means without lifting the pen from the paper, you cannot draw this graph. You can see from the graph that without lifting the pen from the paper, you cannot draw it. That means the function is not continuous and specifically not continuous at x equal to 0. Let us take another example. Let fx is equal to 1 if x is not equal to 0 and is equal to 2 if x equal to 0. Now first thing is the function is defined at each and every point. The left hand and right hand limits at x equal to 0 are both equal to 1. Why? Because when x is not equal to 0, fx has the value 1. So from left hand side and right hand side both the limits are equal to 1. But the value of the function at x equal to 0 is equal to 2. At the point x equal to 0, the value of the function is 2. And this value does not coincide with the common value of the left hand and right hand limits. Again, if you draw the graph of this function, you cannot draw it without lifting the pen. So the function is not continuous at x equal to 0. So let us define. Suppose f is a real function on a subset of the real numbers and let c be a point in the domain of f. Then f is continuous at c if limit x tends to c fx is equal to f of c. Or in other words, a function is continuous at x equal to c if the function is defined at x equal to c and if the value of the function at x equal to c equals the limit of the function at x equal to c. Now, if f is not continuous at c, we say that f is discontinuous at c and c is called the point of discontinuity. In easy language, a function is continuous at a fixed point if we can draw the graph of the function around that point without lifting the pen from the plane of the paper. A real function f is said to be continuous if it is continuous at every point in the domain of f. That means, in short, if we want the conditions for continuity, a function is said to be continuous at a particular point A if the following conditions are satisfied. First of all, f of A is defined, limit x tends to a fx exists, and the right hand and left hand both the limits are equal and both are equal to f of A, means the value of the function at the point A. Let us take an example. You have to discuss the continuity of the given function. Now the function fx is equal to mod of x at x equal to 0. You have to discuss the continuity. Now what is the definition of mod function? Mod function means it will always take positive value. That means if x is greater than or equal to 0, the value of the function is x. But if x is less than 0, the value of the function is minus x. The function is defined as 0, we know that, and f of 0 is 0. This is also there. Now let us find the left and right hand limit. Left hand limit of f at x equal to 0 will be limit x tends to 0 minus, means from the left hand side of fx. Left hand side of fx means you have to take the case when x is less than 0. So it is limit x tends to 0 minus, when x is less than 0, how is fx defined? As minus x. So the value is 0. Again, the right hand side limit is limit x tends to 0 plus fx, which is equal to limit x tends to 0 plus right hand side. What is the definition of the function? X. That means again over here also the value is 0. The left hand and right hand limits are same and they are same as the value of the function at x equal to 0. Hence in this case we can say the given function is continuous at the point x equal to 0. Now for the same function, but see how, let us check it out that whether it is continuous at all other points or not. At x equal to 0 we saw it is continuous. Now the function is mod x. First case is f, we have to check the different cases, that means you have to check for 0 and when x is less than 0 and when x is greater than 0. So 3 cases will arise. First case we have already seen previously, f is continuous at x equal to 0. Second case, let c be any real number so that c is less than 0. Then f of c will be equal to minus c. This is how the definition of mod function goes. That means limit x tends to c from the negative side, that means limit x tends to c minus of fx is equal to limit x tends to c when x is less than 0. How it is defined? As minus x. So limit x tends to c minus, the function is minus x, the value is minus c, correct, which is equal to f of c. So the function is continuous for all negative real numbers. Same way for the positive real numbers. When c is greater than 0, the value of the function at c will be, f of c will be equal to c. Therefore, limit x tends to c plus fx is equal to limit x tends to c plus, in this case it is x, that is equal to c, which is equal to f of c. So f is continuous at all positive real numbers also. So in short, by all the 3 cases you can say that f is continuous at all the points on the real line. Example 2. Discuss the continuity of the function fx is equal to cosec x. So these are the trigonometric functions. So now first of all, fx is equal to cosec x means 1 upon sin x, correct. Now put x is equal to a plus h. That means when your x will tend to a, what will your h? H will tend to 0, correct. Limit x tends to a, 1 upon sin x is equal to limit h tends to 0. Now we have changed from x tends to a, we have taken as h tends to 0. 1 upon sin of x, x is a plus h, which is equal to limit 1 upon limit h tends to 0 sin of a plus h. Sin a plus b formula you know, sin a cos b plus cos a sin b. So just put that. Now when h is 0, you know that cos 0 is 1 and sin 0 is 0. So this is equal to 1 upon sin a, which is nothing but the value of the function at a, which is equal to f of a. So what we have shown is limit x tends to a, fx is equal to f of a. So f is continuous for any, and this a is arbitrary real number. So f is continuous for any a belongs to R. Hence the cosec function is a continuous function. Second case, to check the continuity of the function fx is equal to sin x into cos x. Again take x is equal to a plus h. So as x tends to a, your h will tend to 0. Limit h tends to 0, f of a plus h will be equal to limit h tends to 0 sin of a plus h into cos of a plus h, correct. So now limit h tends to 0, sin a plus b formula you know and cos a plus b formula. Just put that formula, cos a plus b is cos a cos b minus sin a sin b. So just put the values. You know that cos of any angle, cos of 0 is 1 and cos of sin of 0 is 0. So just put those values. So this is equal to sin a into cos a, which is equal to f of a, the value of the function at the point a. Hence limit x tends to a, fx is equal to f of a. Thus f is continuous at x equal to a. Next example. Find all points of discontinuity for the following functions. The first function fx is defined as 2x if x is less than 0. If x is between 0 and 1, the function has value 0, and if x is greater than 1, it is defined as 4x. So now you can see at x equal to 0 and x equal to 1, we need to check the continuity. At x equal to 0, the left hand limit will be limit x tends to 0 from the left hand side, negative side. So the function is defined as 2 into x. So 2 into 0 will give you 0. From the right hand side, limit x tends to 0 plus means x approaches 0 from the right hand side. In this case, the function is defined as 0 because when x is between 0 and 1, the function is defined as 0. So the value is 0. At the left and right hand limits are same. So f is continuous at the point x equal to 0. At x equal to 1, let us check. As x tends to 1 from the left hand side means you are going to take the definition of x as 0 when x is between 0 and 1. So you are going to use this in left hand limit. So left hand limit x tends to 1 minus 0 is 0. Right hand limit will be limit x tends to 1 plus means from the positive side, from the right hand side, when x tends to 1, the function is defined as 4x, correct? And when you put x equal to 1, you get 4 into 1, which is 4. So now in this case, left hand limit and right hand limit are not equal, so function is discontinuous at x equal to 1, correct? Now when x is means at x is equal to 0, we found it is continuous. At x equal to 1, it is discontinuous. So now at x, if the x value is less than 0, fx is equal to 2x. Now this is a polynomial function. Remember, all polynomial functions are always continuous. So fx is equal to 2x is a polynomial function and hence it is a continuous function when x is less than 0, because this is how it is defined. When x is greater than 1 also, fx is equal to 4x. It is also a polynomial function and hence it is continuous when x is greater than 1. So in short, when x is equal to 1, you just get one point of discontinuity, which is x equal to 1. Therefore, for this function x is equal to 1 is a point of discontinuity. Next function is fx is equal to 2x plus 3 if x is less than or equal to 2 and 2x minus 3 if x is greater than 2. Now, it is defined for x less than or equal to and x greater than 2, correct? So now it is continuous on r minus 2, on r because both are polynomial functions, 2x plus 3 and 2x minus 3. So for less than or equal to 2 and for greater than 2, that means the function is continuous for r minus 2. Only we need, because there are two definitions of fx, we need to check for continuity at x equal to 2. So for x equal to 2, the left hand limit is limit x tends to 2 from the left hand side. In this case, how is it defined? 2x plus 3. Just put x as 2. You will get the value as 4 plus 3, 7. Right hand limit x tends to 2 plus fx. Here it is defined as 2x minus 3 in this case. So again put x equal to 2. The value is 1. The left and right hand limits are not equal. So the limit of the function at x equal to 2 obviously does not exist and f is discontinuous at x equal to 2. Example 4. Find all the points of discontinuity of the greatest integer function defined by fx is equal to box of x, where box of x denotes the greatest integer less than or equal to x. We have discussed this function previously also. It is an important function. It gives the greatest integer which is less than or equal to the given number. Now two cases are there. First case, if suppose it is not an integer, that means let c be a real number which is not an integer. Then limit x tends to c of fx is limit x tends to c of box of x, which is same as box of c. So that is equal to f of c. Hence limit x tends to c fx is equal to f of c. So the function is continuous for all real numbers which are not integers. Second case is if suppose it is an integer. So we will find the left hand limit and right hand limit. Now for example, suppose if your number is a, if your integer is a and a is equal to 2, then as your x approaches 2 from the left side, means say for example if you are having 1.99, then the integer function value will be 1. But if your x approaches 2 from the right hand side, say 2.1 something like that, then the greatest integer function value will be 2. So it will be different. Left hand limit means as x approaches a from the left side where x is less than a. In this case, your box x means fx will be equal to a minus 1. Correct? Therefore, the left hand limit x tends to a minus of fx is a minus 1. While for the right hand limit, as x approaches a from the right hand side, means x is greater than a, fx will be equal to a. Therefore, the right hand limit will be a. X tends to a plus of fx is a. Since both are different, the limits, right hand and left hand limits are not equal, so a function will not be continuous. So what we have concluded is the GIF function is discontinuous at every integral point. Discuss the continuity of the function fx is equal to mod x by x if x is not equal to 0, is equal to 0 if x equal to 0. Now first of all, you know that the mod function, mod of x is equal to x if x is greater than 0, and mod x is equal to minus x if x is less than 0. For example, mod of 2 is 2, but mod of minus 2 is minus of minus 2, which is 2. So two cases, for x greater than 0, fx is equal to, now mod x will be x if x is greater than 0. So function will be x upon x, which is 1. And for x less than 0, fx will be, mod x will be minus x. So fx will be minus x upon x, which is minus 1. Now at x equal to 0, the value of the function is given to us as 0. Let us find the left hand and right hand limits. Limit x tends to 0 minus fx. In this case, which definition will you apply? It will be equal to minus 1 because x tends to 0 from the left side, means x is less than 0. So in this case, the left hand limit is minus 1. Similarly, limit x tends to 0 plus of fx. In this case, the function is 1. Correct? Both right hand and left hand limits are not equal. So at limit x tends to 0 fx, means at x tends to 0 fx does not exist. That means your fx is discontinuous at x equal to 0. And obviously for x greater than 0 and less than 0, both are constant functions, 1 and minus 1. So obviously they are continuous. So it is just discontinuous at x equal to 0. In short, fx is continuous on r minus 0. Next example. Discuss the continuity of the given function fx is equal to mod x minus mod of x plus 1. First of all, the mod function, how is it defined? Mod x value will be equal to x if x is greater than 0, and it will be equal to x minus of x if x is less than 0. For example, say if you are having mod of 2, it is 2. But if you are having mod of minus 2, it is minus of minus 2, which is 2. So mod x is equal to x if x greater than 0, and mod x is equal to minus x if x is less than 0. Now since you are having the function as mod x minus mod of x plus 1, three cases will arise. In the first case, if x is less than minus 1. In this case, how is your function defined? Fx is equal to, since it is negative, mod x will be minus x. Minus, again x plus 1 will also be negative because x is less than minus 1. So that will be minus of x plus 1. So minus x minus minus of x plus 1. So it is 1. Second case is if x is between minus 1 and 0, means minus 1 less than or equal to x less than 0. In this case, mod x will be minus x. Mod of x plus 1, since x is greater or than equal to minus 1, x plus 1 will be over here positive. So in this case, mod of x plus 1 will take the value just x plus 1. So our function is minus x plus 1, which is equal to minus 2x minus 1. And the third case is if it is greater than or equal to 0, x will be x and mod of x plus 1 will be x plus 1. So fx is equal to minus 1. So now our proper definition of fx is 1 if x is less than minus 1. Fx is minus 2x minus 1 if minus 1 less than or equal to x less than 0. And it is minus 1 if x is greater than or equal to 0. Now over here we can see from the function that we need to check the continuity at 2 points, x equal to minus 1 and x equal to 0. At x equal to minus 1, the left hand limit x tends to minus 1, minus means from the left hand side, that will be equal to, by the definition of x which we have just given, it will be equal to 1. And limit x tends to minus 1 from the positive side, it is defined as minus 2x minus 1. In that, when you put x as minus 1, you will be getting the answer as minus 2 into minus 1, which is 2 minus 1 is equal to 1. Both are equal. So at x equal to -1, the function is continuous. Now at x equal to 0, limit x tends to 0 from the left side. Left side means in this case x is approaching 0 from the negative side. So how is the function defined? It is in the range -1 to 0. So -2x minus 1. Put x as 0, it is -1. And the limit x tends to 0 plus means from the positive side, right hand side of fx, it is defined as -1. Both are same. So again at x equal to 0, the function is continuous. Example 6. A different kind of example. Find the values of a and b such that the function defined below is a continuous function. It is given that the function is continuous. You have to find the values of unknowns a and b. Fx is equal to 5 if x is less than or equal to 2. Ax plus b if x 2 less than x less than 10 and is equal to 21 if x is greater than or equal to 10. Correct? Now you know that the function is continuous. So at which points do we need to check? First point is x equal to 2. So at x equal to 2, limit x tends to c from the left hand side, means the left hand limit. In this you will apply 5, the definition of function, which says fx is 5 for x less than or equal to 2. So this limit is 5. Limit x tends to 2 from the right hand side of fx, that means it is the second case. X is greater than 2. So in this case the function is defined as ax plus b. In this you put x as 2. So limit x tends to 2 plus ax plus b is 2a plus b. So now since it is continuous, the left hand and right hand limit at x equal to 2 should be equal. So 2a plus b equal to 5. This is the first equation. Similarly, it is continuous at x equal to 10. So limit x tends to 10 from the left hand side, means when your x is less than 10, x approaches 10 from the left hand side. Which, what is the definition? Ax plus b. So here put x as 10. So limit x tends to 10 minus is ax plus b is equal to 10a plus b. Similarly, limit x tends to 10 from the right hand side. In this case, you will apply the third case of definition of fx. X greater than or equal to 10. How is the function defined? 21. So this is equal to 21. So the second equation is 10a plus b equal to 21. Solving both the linear equations, you get a equal to 2 and b equal to 1. Next example. Find the value of k so that the function f defined as fx is equal to k cos x upon pi minus 2x if x is not equal to pi by 2 and is equal to 3 if x equal to pi by 2. At pi by 2, this function is continuous. Correct? If the function, given function is continuous at x equal to pi by 2, you have to find the value of unknown k. Now at x equal to pi by 2, since the function is continuous, its left hand and right hand limit should be equal. So limit x tends to pi by 2 from the left hand side, means limit x tends to pi by 2 minus of fx. How is it defined? It will be defined as f of pi by 2 minus h. Now as x tends to pi by 2 from the left hand side, your h will tend to 0. Since it is from the left hand side, so you have to apply f of pi by 2 minus h because it approaches pi by 2 from the left side. So for a very small quantity h, limit h tends to 0, your function is f of pi by 2 minus h. So now in the given function, you put your h as limit h tends to 0, k cos x, x as pi by 2 minus h, pi minus 2 into pi by 2 minus h. Now you know that pi by 2 minus h means the first quadrant. So everything is positive. So cos of pi by 2 minus h will be sin h. And always remember this, when you are applying pi by 2, the function will change. So cos will change to sin. So it will be k sin h upon 2h. So k by 2 is constant, take out. So it is limit h tends to 0 sin h by h. Now you know this, limit h tends to 0 sin h by h is always 1. So this left hand limit is k by 2. Now the right hand limit. Limit x tends to pi by 2 plus, means from the right hand side. So here what will your x be? Your x will be something plus pi by 2 plus something, which is a very small quantity. So it is limit h tends to 0, f of pi by 2 plus h. So this is limit h tends to 0. Again, instead of x, put pi by 2 plus h. Pi by 2 plus h means in the second quadrant. Correct? So cos will change to sin, but in the second quadrant only sin is positive, so cos is not positive. So it will be minus of sine h upon minus 2h. So again over here take k by 2 outside. So it is limit h tends to 0 minus sine h upon minus h, so which is 1. Again this is k by 2. Correct? Now fx is continuous at pi by 2. So pi by left hand and right hand limits are same, which is pi by 2, that we have checked, and this is same as the value of the function at the point pi by 2. So f of pi by 2, this is given to us as 3. So you just have to equate your left hand and right hand limit to 3. In fact, if you just find one of the limits also, it is okay, left hand or right hand, because it is given that the function is continuous. So both left hand and right hand limits should be equal, and both of them should be equal to the value of the function at pi by 2. So f of pi by 2 is 3. So your k by 2 should be equal to 3, means k equal to 6. Now some theorems. Suppose f and g are two real functions which are continuous at a real number c, then f plus g is also continuous at c, and also f minus g, f into g, and f upon g. All the four functions are continuous. Second theorem says, suppose f and g are real valued function, then f of g is defined as c. You know composition of two functions. So if f and g are real valued function, then f of g is defined, and if g is continuous at c and f is continuous at g of c. Remember, for f of g the condition is if g is continuous at c, and if f is continuous at g of c, then f of g is continuous at c. Example 8. Show that the function f defined by fx is equal to mod of 1 minus x plus mod x whole mod, where x is any real number, is a continuous function. Now, first of all, we have just studied the theorems for composition of functions. So let us define the function g of x as 1 minus x plus mod x, and the function hx by just mod of x for any real number x. So what will be h of g of x? It will be h of g of x, means h of, what is g of x? 1 minus x plus mod x. And what does the function h do? It applies mod to whatever is there inside the bracket. So it will be mod of 1 minus x plus mod x, and this is nothing but our fx. So we have shown that h of g of x is fx. Now already, if you remember, in one of the previous example we had shown that mod x is a continuous function, correct? So again mod x is continuous function, means our hx is continuous function. Also g is a sum of polynomial function and the mod function, which are both individually continuous. So again, by applying the previous theorem, you know f plus g will always be continuous. So what we have shown is our h and g both are continuous. F being a composite of two continuous functions, it is also a continuous function. Some assignment examples. Discuss the continuity of the function f defined by fx is equal to 1 upon x, x not equal to 0. The answer is f is continuous for all x belongs to r minus 0. Why? Because the function is continuous in minus infinity to 0, union 0 to infinity. But at x equal to 0, it is discontinuous. Why? Because the limit itself does not exist at x equal to 0. Show that every polynomial function is continuous. You just have to use the fact that limit x tends to c, p of x is nothing but p of c for every real number c. Prove that every rational function is continuous. Here you just express the function in the form of fx upon gx and prove it is continuous. Continuity and differentiability of functions is an important topic. Hope the first part, which is continuity of functions, is understood. Do like and share the video and subscribe to the channel for the next part on differentiability.